Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is section 4.4 Indeterminate Forms and L'Hopital's Rule. We will talk in this lecture, in this video, about indeterminate forms of types 0 over 0 and infinity over infinity. L'Hopital's rule. Suppose f and g are differentiable. The derivatives exists. G prime is not 0 because G would be in the denominator. And limit of f is 0 and limit of g is 0. This means that limit f over g would be 0 over 0. Or limit f is positive negative infinity and limit g is positive negative infinity. This means that we have positive negative infinity over positive negative infinity when we find the limit of f over g. If this is the case, if limit of f over g is either 0, 0 or infinity over infinity, then L'Hopital's rule says that limit of f over g is exactly equal to limit f prime over g prime. That's the L'Hopital's rule. Notice that x approaches a can be replaced by any of the symbols. X approaches infinity, negative infinity, a plus, a minus, any limit. And L'Hopital's rule says that the limit of a quotient of functions, f over g, quotient of functions, is equal to the limit of the quotient of their derivatives, limit f prime over g prime, provided, of course, g of x is not 0, g prime of x is not 0. Example. Replace x by 1, len 1 is 0. X minus 1, 1 minus 1 is 0. So we have 0 over 0. So we can use L'Hopital's rule. And whenever you need to use L'Hopital's rule, please write H here so we understand that you are going to use L'Hopital's rule. So find the derivative of len x. It is 1 over x. The derivative of x minus 1 is 1. Now replace x by 1. 1 over 1 is 1. So the limit is 1. Note that we differentiate the numerator and the denominator separately. We are not using the quotient rule here. There is no quotient rule in L'Hopital's rule. L'Hopital's rule says limit f over g, limit f prime over g prime. We are not using the quotient rule. Replace x by infinity. E to the power infinity is infinity. Infinity square is infinity. I have infinity over infinity, so I can use L'Hopital's rule. Derivative of ex is ex. Derivative of x squared is 2x. Replace x again by infinity. E to the power infinity is infinity. 2 times infinity is infinity. I can use L'Hopital's rule once more. Derivative of 2x is 2. Replace x by infinity. E to the power infinity, infinity over 2. Infinity over 2 is just infinity. So the answer is infinity. Len infinity is infinity. Square root of infinity is infinity. Of course, len infinity is infinity because of the graph of len. So I can use L'Hopital's rule. Derivative of len x is 1 over x. Derivative of square root of x is 1 over 2 square root of x. Now I need to simplify this. So let us simplify it. 1 over x divided by 1 over 2 square root of x is 1 over x times 2 square root of x over 1. So this is 2 square root of x over x. And I can subtract the powers, x to the power half, and this is x to the power 1. So I will have x to the power half in the denominator. So this is in fact is 2 over square root of x. Square root of infinity is infinity. 2 over infinity is 0. So that's the limit. If you have any problem with infinity, please check the limits uh, in chapter 2, especially limits at infinity. So infinity over 2 is infinity, 2 over infinity is 0. We know this. Tan 0 is 0 minus 0, so I have 0 up, 0 down. I can use L'Hopital's rule. Whenever you have 0 over 0, infinity over infinity, you can use L'Hopital's rule. The derivative of tan x is secant square x minus the derivative of x over the derivative of x cubed. Replace x by 0. Secant 0 is 1. 1 minus 1 is 0, so I have 0 over 0. I use L'Hopital's rule again. What is the derivative of secant square? Using chain rule, this is 2 times secant x times the derivative of secant x, which is secant tan. So I'll have secant square tan x. The derivative of 1 is 0. The derivative of 3x squared is 6x. Tan 0 is 0, and 6 times 0 is 0. So this is again 0 over 0. I'll use L'Hopital's again. I can simplify this. Okay, derivative of secant square x tan x, I'll use the product rule. Derivative of secant square is 2 secant x times the derivative of secant x, which is secant tan. So I'll have square here, tan x, times tan, so the derivative of the first function times the second function. So this would be square, plus secant square times the derivative of tan. Derivative of tan is secant square. So I'll have here secant to the power 4. Derivative of 3x is 3. Now replace x by 0. Tan 0 is 0, so the first term cancels. Secant 0 is 1. So the answer is 1 over 3. Replace x by pi. Sine pi is 0. Cosine pi is negative 1. So the answer would be 0 over 1 minus 1. 0 over 2, so the limit is 0. So here we did not use L'Hopital's rule. We can't use L'Hopital's rule because it is not 0 over 0 or infinity over infinity. So directly we have the answer. Some exercises, replace x by 4. 4 squared 16 minus 8 minus 8, so that's 0. 4 minus 4 is 0. So I'll use L'Hopital's rule. If you remember, I can solve this question by factoring. We learned how to solve this by factoring in chapter 2. Factoring the numerator will give you x minus 4 times x plus 2. So you can cancel x minus 4 with x minus 4, replace x by 2, and the answer would be 6. So this is the old method. You can apply it, no problem. But here I'm going to use L'Hopital's rule. So the derivative of the numerator is 2x minus 2. Derivative of the denominator is 1. Replace x by 4. 2 times 4 is 8 minus 2 is 6. And you have the same answer. If x is 4, you will have 0 over 0. We used to solve this problem by multiplying by the conjugate or by factoring x minus 4 into square root of x minus 2 times square root of x plus 2. So if you multiply by the conjugate, you will have x minus 4 over x minus 4 times square root of x plus 2. Now when you replace x by 4, square root of 4 is 2, 2 plus 2 is 4, so the answer would be 1 over 4. But I can use L'Hopital's rule also because I have 0 over 0. The derivative of the square root of x is 1 over 2 square root of x. Derivative of x minus 4 is 1. Replace x by 4, square root of 4 is 2, 2 times 2 is 4. The answer is 1 over 4. So you have two methods now to solve such problems. Sine pi over 4 is 1 over square root of 2. Cosine pi over 4 is also 1 over square root of 2. So you will have 1 over square root of 2 minus 1 over square root of 2, that's 0. Tan pi over 4 is 1. 1 minus 1 would be 0. So I can use L'Hopital's rule. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tan is secant square. Derivative of 1 is 0. Now cosine pi over 4 is 1 over square root of 2. Sine pi over 4, 1 over square root of 2. Secant pi over 4 is square root of 2 squared. So I have 2 over square root of 2 over 2, or 2 over square root of 2 times 1 over 2. So the answer is 1 over square root of 2, or if you rationalize the denominator, square root of 2 over 2. Tan 0 is 0, sine 0 is 0. We had a method before to solve this problem. We said that to solve this problem, we divide by x in the numerator and in the denominator. And then we multiply by 3 over 3 and 2 over 2. Because we know that limit tan 3x over 3x is 1. And limit sine 2x over 2x is 1. So the answer would be 3 over 2. But I can use also L'Hopital's rule here. Derivative of tan is secant square. Derivative of 3x is 3. Derivative of sine is cosine. Derivative of 2x is 2. Secant 0 is 1. Cosine 0 is 1. So the answer is 3 over 2. E to the power 0 is 1. 1 minus 1 is 0. Sine 0 is 0. I can use L'Hopital's rule. Derivative of e to the power 2t is e to the power 2t times the derivative of 2t. Derivative of 1 is 0. Derivative of sine is cosine. E to the power 0 is 1 times 2. Cosine 0 is 1, so the answer is 2. Sine 1 minus 1, sine 0, 0. 1 plus 1, 2 minus 2, 0. I can use L'Hopital's rule. Derivative of sine is cosine. Derivative of x minus 1 is 1. Derivative of x cubed, derivative of x is 1, negative 2, derivative 0. Replace x by 1. 1 minus 1 is 0, cosine 0 is 1. 1 times 3, 3 plus 1 is 4, so the answer is 1 over 4. I think we can solve this problem by multiplying by the conjugate. But if I replace theta by pi, cosine pi is negative 1, so I have 0. Cosine pi is negative 1. All right. So 1 plus cosine 0 pi is -1. Cosine pi is -1. So I have 0 over 2. So the answer is 0. There is no L'Hopital's here because the limit is not 0 over 0 or infinity over infinity. 3 over 3 is 1. Ln 1 is 0. I have 0 over 0. This is 1. And ln 1 is 0. So I use L'Hopital's. Derivative of ln x over 3 is 1 over x over 3 times the derivative of x over 3, which is 1 over 3, over derivative of 3 minus x is -1. Let us simplify this. Now this -1, you can take it up. So I have -1 over 3 times x over 3. And now I have limit -1 over x. When I replace x by 3, I get 3. So that's the answer. 8 to the power 0 is 1. 5 to the power 0 is 1. 1 minus 1 is 0 over 0. I can use L'Hopital's. Derivative of 8 to the power t is 8 to the power t times ln 8. Derivative of 5 to the power t is 5 to the power t ln 5. Derivative of t is 1. 8 to the power 0 is 1 times ln 8. 5 to the power 0 is 1 times ln 5. So that's the answer. Or you can write it ln 8 over 5. E to the power 0 is 1. E to the power 0 is 1 over e to the power 0 is 1. E to the power 0 is 1 minus 0, x is 0. So I have 1 minus 1, I have 0 over 0. I use L'Hopital's. Derivative of e to the power x. Derivative of e to the power negative x would be minus e to the power negative x. Derivative of 2 is 0. Derivative of negative x is -1. Replace x by 0. E to the power 0, 1 minus 1, 0. E to the power 0, 1 minus 1, 0. Use L'Hopital's again. E to the power x plus e to the power negative x. That's the derivative. E to the power x. E to the power 0 is 1. E to the power 0 is 1. So the answer is 2. Since 0 is 0, you can check that either by hyperbolic in the calculator or by using the definition of sinh. More information in section 3.11. Sinh 0 is 0 minus 0, so I have 0 over 0. So I use L'Hopital's rule. Derivative of sinh is cosh. Derivative of x is 1. Derivative of x cubed is 3x squared. Cosh x is e to the power x plus e to the power negative x over 2. If you replace x by 0, 1 plus 1, 2 over 2, it is 1. 1 minus 1 is 0 over 0. I use again L'Hopital's rule. Derivative of cosh is sinh. This is 6x. Sinh x by definition, e to the power x negative e to the power negative x over 2. Sinh 0 would be 1 minus 1, 0. I have 0 over 0. Again, I use L'Hopital's rule. Cosh 0 is 1. So the answer is 1/6. Hyperbolic tan of 0 is 0. Hyperbolic tan is hyperbolic cosine, hyperbolic sine over hyperbolic cosine. So that's the definition. So if I replace x by 0, 1 minus 1, 0 over 2, so it is 0 over 0. Tan 0 is 0. I use L'Hopital's rule. Derivative of tan hyperbolic tan is hyperbolic secant square. Derivative of tan is secant square. Secant 0 is 1. Hyperbolic secant is the reciprocal of cosine. So e to the power 0, 1 plus 1, 2 over 2. Hyperbolic secant of 0 is 1. So I have 1 over 1 and the answer is 1. This is a product x times 3 to the power x, 0, and 3 to the power 0 is 1 minus 1, 0 over 0. Use L'Hopital's. Derivative of product rule. Derivative of x is 1 times 3 to the power x. X times the derivative of 3x, which is 3x times ln 3. Derivative of 3x is 3x times ln 3 minus the derivative of 1, which is 0. Now replace x by 0. 3 to the power 0 is 1. And this is 0 times anything would be 0. 3 to the power 0 is 1 times ln 3 is ln 3. So the answer is 1 over ln 3. If x is 0, 1 plus 1, 2 minus 2, 0 over 0. So I use L'Hopital's. Derivative of ex, derivative of e negative x, derivative of cosine is negative sine. Product rule, derivative of x is 1. Times sine x. Derivative of sine is cosine. Replace x by 0. 1 minus 1, 0 plus 0, 0. 0 plus 0 times cosine, that's 0. Use L'Hopital's again. Derivative of ex. Derivative of e to the power negative x. Derivative of sine is cosine. Derivative of sine is cosine. Product rule. Derivative of x is 1. Derivative x times derivative of cosine is negative sine. Replace x by 0. E to the power 0 is 1. E to the power 0 is 1. Cosine 0 is 1. 2 times 1 is 2. Cosine 0 is 1. Cosine 0 is 1. 0 times 0 minus 0. So 2 plus 2, 4 over 2. So the answer is 2. This is the last question. I hope you understand L'Hopital's rule and when do we use it.